Welcome to Brain Vision.
So continuing on with our work around physical chemistry, the first equation that you'll need, just to offer some context, we have V is equal to pi r cubed H. We can calculate the volume of N octane used in 24 hours. So we substitute in 18 minus 8 feet a day for H, 3.14 for pi, and 30 foot divided by 2 squared for R squared. So we have V is equal to 18, take away 8 feet a day, multiplied by 3.14, multiplied by 30 feet divided by 2 squared. Volume is 7.069 times 10 to the 3 feet cubed per day. We can convert that to gallons per day. We get 5.288 times 10 to the 4 gallons per day. So then we have the volume of octane, that's 5.288 times 10 to the 4 gallons per day, the density of water, and the specific gravity. We can calculate the mass of octane used. So we have M is equal to V times Sg times the density of H2O. M is equal to 3.10 times 10 to the 5 pounds per day, after subbing in all of those values that we just mentioned. In part B, now that we have the partial pressure, the height, we know the conversion between feet and inches, so 1 foot squared is 12 inches squared, which is 144 inch. So the pressure, that is the maximum, is equal to 73.68 inches mercury. Then we can calculate the P minimum. That is 67.47 inches of mercury. So we can calculate the pressure differences. So delta P is equal to 73.68. Take away 67.47, that's 6.21 inches of mercury. So moving on to the next part here, so we have some values that we need to take from the table. Partial pressure of octane, 1 atmosphere is equal to 760 millimeters of mercury. 1 atmosphere is equal to 14.696 psi. So we convert millimeters of mercury to pounds per square inch. So we have P is equal to 0.40 psi. That is the partial pressure of octane. And the volume of octane, we have V is equal to 5.288 times 10 to the 4 gallons that we previously calculated, multiplied by 1 foot cubed divided by 7.481 gallons for the conversion. So the volume is 7069 foot cubed. That is the volume of octane in cubic feet. So the pressure, we have 16 at 14.7 psi. The volume is 7069 feet cubed. Temperature in degree Rankine is 90 at 460, and the gas constant in Rankine is 10.73. We can calculate the number of moles using the following equation. N equals PV over RT. Substitute in our values. We have N 160 at 14.7 psi pressure, volume 769 feet cubed, divided by 8 divided by 10.73 feet cubed psi, pounds per mole. degrees Rankine. Multiply that by 90 at 460 degrees Rankine for that conversion. Moles, 36.77 pounds of moles. So the number of moles of octane is 36.77. So we can calculate the mole fraction of N octane. So we have Y is equal to P, little p divided by big P. Substitute in our values. So we have 0.40 divided by 16, add 14.7, 0.0130 pounds per mole of C8H18 per pounds per mole. So the mole fraction of N octane is 0.0130. So moving on to the next page, we can calculate the octane lost as follows. So we have N C8H18 is equal to NY. Substitute in 36.77 for N, 0.0130 for Y, and N becomes 0.479 pounds per mole. So in air, octane undergoes combustion with oxygen, so air is not used in place of nitrogen, and the octane can be recovered from the discharged gas stream by an absorption or some sort of scrubbing process.